Okay, we're back again. Here's 9.2, solving linear systems by substitution. The essential question says, how can you solve a system of linear equations by using substitution? Now remember, last time we sat there and graphed them, and we realized that whenever we graph more than one line, if they intersect at exactly one point, that was the solution. If they didn't intersect at any point, then there was no solution. And if they were overlapping each other, exactly the same line, then they had infinitely many solutions. So here we want to solve it, but we want to use substitution. So what you'll see is that solve one equation for one of the variables. What variable do you think we're going to solve for? You got it. Y. And substitute the resulting expression into the other equation. Solve for the value of the other variable, then substitute that value into either equation to find the value of the first variable. Whole lot of words. Let's dig right into it. Okay, so here's our vocab substitution. Let's just go over this real quick. I want to make sure that we have a good mind frame. So let's say that y is equal to 2. And I give you something simple like 2 plus y is equal to what? Well, what would you do with this y? Well, y and y are exactly the same. Therefore, the y here and the y here have to be equal to what? 2. And what do you do when you substitute in? Use parentheses. So 2 plus 2 is equal to what? 4. Simply put, that's all substitution is. It doesn't matter what the number is. I can change whatever y is to whatever number, or later on you'll see anything else I want. And I can still substitute that into another equation. Okay, hopefully that just clears up a little bit about your substitutions. Real simple. So if I had y is equal to 6, this 2 plus y transforms into what? 2 plus 6, which we all know is equal to 8. Now, with that being said, here's the question. Can we substitute a whole equation in for y? Well, let's change this word. Let's not use an equation, but let's say expression. Okay, so if I said y is equal to 2 plus x, and let's use the same scenario, it was 2 plus y, what is that equal to? Well, what if I sat there and just plugged the expression in for y? What would happen? Well, you would get 2 plus, use your parentheses, and you got it. Just put the 2 plus x in there. Okay? Naturally, this would simplify down to what? 4 plus x as an expression. Real simple. Doesn't matter what you do when it comes to y is a variable. Therefore, it can change. It could be 2, it could be 6, or it could be an expression, 2 plus x. And we can substitute it in. Remember, a good rule of thumb is just use parentheses. That way you don't mess up any of the signs, and you'll be good to go. Okay. Why solve for y? Well, you have x plus y is equal to 1. What is that? Standard form. In standard form, are you able to graph with ease? No. In standard form, are you able to see what the slope is with ease? No. So if we solve for y, what format do we get in? Well, we can change standard form to what? Slope, intercept, form. And you're probably saying, so what? Who cares? If standard form is ax plus by is equal to c, why does y equal mx plus b make it better for me? Well, you know it. M is what? Slope. What's another way of saying slope? Rise over run. What does the rise tell me to do? Go up or down. What does run tell me to do? Go left or right. Now, b is what? It is considered your y-intercept. We know that the y-intercept, x will always be 0. So what is the value of the y? the b. And now I have a plot, a coordinate pair here that I can actually plot, then use the slope to get the second point. Does that make sense? So if I have an equation here, x plus y, and I decide to solve for y, whenever we solve for something, what do we use? 4 steps. So simplify / combine like terms, nothing to do. Second step, remove all addition and subtraction. From where? Near your variable. So I'm able to take that away. I get y equals 1 minus x. Y is all alone. So I did my job. I have y equals negative x plus 1. Because these say y equals mx plus b. And I showed you before, the b is right there. The m is right there. Just because that negative is there and there's no number, there's an understood 1. There's an understood 1 to be there, okay? So now, b is equal to 1. So my y-intercept is 0, 1 with ease. The slope is negative 1. I can put it as a fraction, just put it over 1. So we said the slope was equal to what? Rise over run. So it tells me what to do. Negative 1 for a rise is go down 1. 1 is positive, so it says go right 1. So if I start at 0, 1, and I go and plot it, then I can go down 1, right 1, and that will give me my second point. And we know that in order to draw a line, how many points do you need? You need 2. That is the reason why slope-intercept is so powerful. Okay? Solving systems by substitution. Okay, I have 2 equations. Here's my system. They're both linear. I have an x and a y, no powers. Okay, but if you notice, is y alone? No. Is x alone? No. So all you have to do is what? Pick one equation and do what? Solve for y. Real simple, okay? All right. Since this one's on the bottom, let's just go ahead and pick this one. It doesn't matter which one. So 4x plus y is equal to 8. We are going to solve for y. Notice I keep circling what variable I am solving for. Why? It's just a visual thing. It doesn't really do anything with the math part of it, but it's a visual thing. It lets me know I need this alone. No coefficients except for 1, and nothing else can be around it. Okay, so here we go. First step, simplify / combine like terms. Anything to do? No. Step 2, remove all addition subtraction. From where? Near your variable. So I see a plus 4x. Well, what am I going to do? The inverse, which says subtract. So I say negative 4x. Now, in math, law of equality, I am going to subtract 4x on the other side. What I do to one side, I must do to the other. So here we go. 4x minus 4x. That goes to 0. Nothing happens to the y, so bring it down. Never forget your equal sign. Put equals. 8 is a constant. Bring it straight down. Negative 4x is in its own family. Notice I keep everything in columns. Makes everything simple. You can visually see if you make any mistakes. Okay? So now here we go. We got a 3 here. Step 3. Do I have to do it? No. Why? Because my coefficient is 1. I am done. In step 4, we really haven't talked about, which is simplify. If I'm done at step 3, that means there's nothing else to simplify. Okay? Why am I switching them? Remember, carry the signs. If you notice, this will always get me into what format? Now, you don't have to do this. You should be able to see it, but at the same time, visually, I want to make sure that for those who struggle sometimes with math and think it's overwhelming, I want to make sure that everything is always standardized for you, okay? So we know that y is equal to negative 4x plus 8. So y is equal to this whole expression. And what are we going to do with that? We are going to substitute it into the first one, the first equation. So the first equation says negative 3x plus y is equal to 1. So what are we going to do? We're going to take this and substitute it in for that y. And look what we get. Negative 3x. When you substitute in, what should you use? Parentheses. I get negative 4x plus 8 is equal to 1. Now, here's the beauty of it. Let's make sure that we do this correctly. Start with your 4 steps. What are we solving for? There's only one variable here, an x. So I know I'm going to combine like terms because they're not all together right now. But we have to go in order. So here we go. Simplify / combine like terms. What's the first step? PEMDAS. Anything to do? Nope. So then the next one is distribute. Anything to do? There's a +1 here, so we could sit there and distribute this +1 in. And anytime you times by 1, there's really nothing that's going to happen except for it's going to drop these parentheses. So I'm going to just rewrite it. Negative 3x. 1 times negative 4x is just negative 4x. 1 times 8 is what? Positive 8. And I get that. Real simple, okay? Now, the next thing is remove fractions. Any fractions here? No. The last checklist item is factoring. We haven't gone over that, so there's nothing to factor. But there is what? 2 terms that haven't been combined. So we want to combine like terms. So here we go. Negative 3x minus 4x is what? Negative 7x. You got it. And there we go. They're all combined. I'm ready to go. I can move on to step 2. What's step 2 say? Remove all addition and subtraction from where? Near your variable. I see an added 8. So I'm going to do the inverse. So what am I going to do? I'm going to subtract. If I subtract 8 from this side, I must do it to the other side. And I keep them all in the same column. So here we go. Negative 7x, anything happen to it? Nope. So just bring it down. 8 minus 8, 0. Don't forget your equal sign. 1 minus 8, negative 7. So therefore, here we go. Step 3, because x isn't alone yet. The step 3 says remove all multiplication and division. From where? Near your variable. So what am I going to do? Divide. Why? Because this is negative 7 times x. So I divide by negative 7. Divide by negative 7 over here. Laws of equality. X equals negative 7 divided by negative 7. 1. Do I know what y is equal to? Not yet. But I do know what x is equal to. So what can I do? I can substitute it back in. And here we go. Life is simple. Y equals negative 4. When we substitute in, what do we use? Parentheses. So I put a 1 plus 8. Real simple. Now, all this is what? When we solve. PEMDAS. Notice we are using the 4 steps over and over and over and over and over again. So here we go. Y is equal to negative 4 times 1, just negative 4. And what is negative 4 plus 8? You got it, 4. So now I know that x is equal to 1. I know that y is equal to 4. My answer in a coordinate pair, x and y. So I get 1, 4. And this is my answer. What does my answer mean? Well, I always have to come back to it. This coordinate pair is exactly where those 2 equations, if I graph them, would intersect. Now, let's just go over what we did first. We solved for y here. Then after we solved for y, we substituted it in. And then we solved for x here. And once we knew what x was, we substituted back in and we solved for y again. And that gives us our answers complete, okay? Which gives us a coordinate pair, which is the intersection of those 2 equations, which is our system, okay? So let's try that again. Let's speed up the process. I have 2x plus y is equal to negative 2. And what are we going to do first? You got it. We're going to solve for y. So if I solve for y, 4 steps. Anytime I'm solving for something, I'm using 4 steps. Anything to do for the first step? No. Anything to do for the second step? Yes, I have a plus 2x, so I'm going to do the inverse. So I'm going to subtract it. And if I subtract it on one side, I must do it to the other. 2x minus 2x, 0. Bring down the y. Don't forget your equal sign. Bring down the negative 2, and then bring down the negative 2x. Is y all alone? Yes. Now I'm just going to rewrite it just so we can always make sure that we're in the proper slope-intercept form. So it's right there. What are we going to do with that? I know that y is equal to negative 2x minus 2. We now substitute it in. And we substitute it into what? The second equation. Okay? So the second equation says 4x plus 2. Instead of writing y, what is y equal to? Negative 2x minus 2 is equal to negative 4. Just write it down. Whenever you substitute in, do not do any math operations on it. Just write it down. Get it down correctly. Okay? So now, what are we going to do? You got it. Solve for x. It's the only variable in here. Notice there's 2 of them, so I know I'm going to combine like terms. But again, if I'm solving for something, what do I use? 4 steps. Simplify / combine like terms. I know that immediately I am going to distribute. This 2 goes in here, goes in here. So anything happen to the 4x? Nope. So I get 4x plus, what is 2 times a negative 2? That's correct. Negative 4. So I get negative 4x. What's 2 times a negative 2? Negative 4 is equal to negative 4. Real simple. Are all my terms combined? Nope. So I'm going to stick with step number 1, and I am going to combine like terms. Look at this. 4x minus 4x is 0. And then I get negative 4 equals negative 4. Is that true? Yes. Will it always be true? Yes. Therefore, what are these equations? These equations are the same exact line. So how many solutions are you going to get? You got it. Infinitely many solutions. Does that make sense? So they are dependent of each other. Okay? Really, really simple if that happens. This is the identity. Negative 4 will always be equal to negative 4. So what's the process that we use? First, we solve for y in what? 1 equation. So solve for y in 1 equation. What happened after we found y? You got it. We substitute it in. And what's it? It's an expression. We're going to substitute an expression in to the second equation. Correct? After we do that, what do we have to do? Solve for x, because x will be the only variable left, right? And once we actually get an answer for what x is, what do? Substitute the answer for x back in for y into the first equation. Good. And after we do that, we solve for y again. And if we solve for y again, guess what? The final answer is a coordinate pair. And what does that coordinate pair tell us? It tells us where the graph would intersect. Does that make sense? So here's a step-by-step process by which you could sit there and always go over these systems. And if I want to use substitution, this would lend me to being able to get an answer or a coordinate pair. Okay? Let's use the process that we just had. And this is real simple. Y is equal to 3, so nothing to solve for there. X plus Y is equal to 5. Well, Y is equal to Y. Let's just substitute it immediately in. I have X plus, substitute in, put a 3 is equal to 5. Solve for what? X. Well, all I'm going to do, nothing for the first step. Second step, I'm going to subtract. Minus the 3, minus the 3. X is equal to 2. I know what 2 is. I know what X is. So what do I do with that? I don't have to substitute it back in because I also know what Y is equal to. Now that I know that Y is equal to 3, X is equal to 2, I know the coordinate pair, 2, 3. Real simple, correct? Here's the second problem. I got Y is equal to 2X. So therefore I can substitute that in. 2X plus 3. Whenever we substitute, use what? Parentheses is equal to 40. What are we going to solve for? X. You got it right. So now that I'm solving for X, the first step, I'm going to distribute. Distribute the 3 in. So I get 2X plus 6X is equal to 40. I still have these X's right here. So I need to combine like terms. This is all the first step. So I get 8X is equal to 40. Second step, remove all addition and subtraction from where? Near my variable. Is there any? Nope. So what about the third step? Remove multiplication and division. This says 8 times. So I am going to divide. If I divide by 8, divide by 8, I get X is equal to, you got it, 5. Correct? All right, so now that I know what X is equal to, what can I do? Solve for Y. Well, Y is equal to 2X. And I know what X is equal to, so I can substitute it in. 2 times 5. So, first step, PEMDAS. Now, Y is equal to 10. I know what X is equal to. I know what Y is equal to. So my answer is what? 5, 10. This is your answer. All right, so now Y is equal to an expression. So I need to substitute it in again. 2X plus, instead of putting a Y, I'm going to use parentheses, X minus 4 is equal to 5. Just write it out when you substitute it in. Step 1. I look right here. I am going to what? Distribute. What am I distributing really? There's a positive 1 right there. So I distribute that in, and that makes the parentheses go away. So I have 2X plus X minus 4 equals 5. Why? 1 times X is X. 1 times negative 4 is just negative 4. Really simple. But I still have this X here and this X here. So what should I do? Combine like terms. Now, 2 plus 1, there's an understood 1 there. 2 plus 1, I get 3X. Minus 4 equals 5. Step 2, remove all addition and subtraction. Here, I'm going to add. So if I add 4 right there. So 3x, negative 4 plus 4, 0. Don't forget your equal sign. 5 plus 4 is 9. So what's step 3? Step 3 says remove multiplication and division from where? Near your variable. So I am going to divide. That's the inverse of this multiplication. So there we go. What I do to one side, I must do to the other. I get x is equal to 3. I know what x is equal to. What do I solve for now? Yes, the y. But first, I need to what? Substitute what I know x is back in. And now, the first step will be PEMDAS. I get y is equal to, what's 3 minus 4? You got it, -1. So, what's my answer? X is equal to what? 3. Y is equal to what? -1. This is my answer. This is where both lines do what? Intersect. That's where both lines intersect. The last one, x's are all alone. I could solve for the x, but let's stay true to form. Let's just sit there and solve for y, because if I ask you to graph, if I ask you to use substitution, if I ask you to do elimination, you would be able to do it no matter what, okay? So let's solve for y in this first equation. I have x plus 3y is equal to 4. So what is the first step? Simplify / combine like terms. Anything to do? Nope. What about the second step? Remove addition subtraction from where? Near your variable. Well, here's an added x. So let's sit there and subtract that. We're going to do the inverse. What I do to one side, I must do to the other. Okay. Now, x minus x, 0. Anything happen to the 3y? No. But don't forget your equal sign. Bring down the 4. Bring down the -x. Make sure you're just keeping everything in columns. So now, 3, remove what? Multiplication division from where? Near your variable. That says 3 times y. So I'm going to do the inverse. I'm going to do division. Divide by 3. Remember, what I do to one side, I have to do to the other side. Okay? 3 divided by 3, I get 1. 4 divided by 3. Now, here's where it's 4 divided by 3. I could put 1 1/3, but I'm going to just leave it as an improper fraction. What number is understood to be right there? -1. So I get -1/3 times x. Don't be afraid of the fractions. So here we go. What am I going to do? Substitute that in to the other y. So here we go. -x plus 2. And what's y equal to? Well, it says right there. Well, here's one thing. I always like to be consistent. Let's make sure we got -1/3 x plus 4/3. Real simple. So here we go. Let's substitute that in. -1/3 x plus 4/3 equals 6. Here we go. I'm going to just move this over just a little bit so we can write our steps. Always, always, always write your steps, because I want to make sure that you understand exactly what is going on with each problem. And remember, repetition in math is exactly what you're going to do every single time. So the first thing you're going to do is what? Simplify / combine like terms, which is our checklist. We are going to end up distributing. Now, I'm going to do a little bit of math over here on the side. Remember fractions. I can make 2 a fraction by putting it 2/1. How do I multiply fractions? You got it. Straight across. So I get 2 times -1 is -2. 1 times 3 is 3. Simple math right there, okay? So here we go. I have a -x. 2 times a negative is a negative. So I get -2/3. Don't forget your x. Now 2 times 4/3. Let's do that again. 2, I can make it into a fraction by putting it over 1. Here's a 4, here's a 3. How do I multiply fractions? Straight across. 2 times 4 is 8. 1 times 3 is 3. I'm going to just leave it like that. So I get plus 8/3 is equal to 6. Now remember, PEMDAS, there was nothing. Distribute, we just did. The third step or third checklist item says remove fractions. Do you like these fractions in here? Probably not. So since they're both the same, I can remove fractions. Okay, if I'm going to remove fractions, how do I do it? If I have one denominator, I can multiply both sides by that denominator. Does that make sense? So I'm going to multiply this side by 3. I'm going to multiply this side by 3. So here we go again. Nothing more than distributing. So 3 times that, 3 times that, 3 times that. That's 3 times each term inside the parentheses. And then 3 times is 6. And what do we get? So 3 times a negative x is negative 3x. Here goes another fraction. Now here's the beauty of this. 3 I can make into a fraction by putting it over 1. I'm going to multiply it by this negative 2 over 3. How do you multiply fractions? Straight across. So 3 times negative 2 is what? Negative 6. 1 times 3 is what? 3. And look what happens. Negative 6 divided by 3 is negative 2. So I get negative 2x. Same thing for the other one. I can put 3 over 1, multiply it by 8 over 3. How do you do it? Straight across. 3 times 8 is what? 24. 1 times 3 is 3. What is 24 divided by 3? You got it. 8. So I get plus 8 equals, what's 6 times 3? 18. Now, if you look here, for those who are a little bit more advanced, instead of multiplying straight across, because the numbers could get bigger, the reason why we do it, we can easily simplify by just crossing out the 3's, because 3 divided by 3 is just 1. And I'm left with a negative 2 over 1. Same thing happens here. 3 crosses out, I get 8 over 1, which is just 8. And that's, for those who are a little bit more advanced, okay? So here we go. We're still on track. Here's 2. What am I going to do? I remove fractions. What's the last checklist item? Factoring. Nothing to do there. Step 1 has slash combine like terms. You must combine like terms. So here we go. Negative 3, negative 2 gives me negative 5x plus 8 equals 18. Step 2 says remove all what? Multiplication, addition and subtraction. I have a added 8 here. So I'm going to subtract this 8. Subtract this 8. I'm doing the inverse, right? So here we go. Nothing happened to the negative 5. So I put negative 5x. 8 minus 8 is 0. Don't forget your equal sign. 18 minus 8 is what? 10. Step 3. Remove all what? Multiplication and division. From where? Near your variable. So I'm going to divide. That's the inverse of multiplication. So here's negative 5, negative 5. What am I left with? X equals negative 2. So I know x is equal to negative 2. So I can substitute that in. So y equals negative 1/3. Instead of an x, I'm going to put a negative 2 plus 4/3. What I'm going to do, PEMDAS, I'm going to multiply this out. So y is equal to, I can put this over 1, multiply fractions how? Straight across. Negative and a negative is a positive. So I get 1 times 2 is 2. 3 times 1 is 3 plus 4/3. Can I add those fractions together? Yes. Why? Because they have the same denominator. Life is easy. Same denominators. So I can sit there and add them. Y equals 2 plus 4. What's 2 plus 4? 6. What's my denominator? It stays the same, which is equal to 3. Now I can simplify that further with PEMDAS. Because now I can divide. I get y equals 2. So x is equal to negative 2. Y is equal to 2. So my answer is negative 2, 2. And this is where both of those intersect. So I wanted to make sure you saw one with fractions, just to make sure that you don't panic when we get to fractions. But here is how we did it. We solved for y. After we solved for y, we substituted into the other equation. We solved for x, and we found out what x was. And once we knew what x was, we substituted back in, and then we solved for y. And once we got y is equal to 2, we're able to write a coordinate pair. And that coordinate pair is where both of those equations, if graphed, would intersect. Practice problems, put it all together. I want you to be able to put all this together. We will work on these problems together when I see you during our Zoom session, and I will have this all worked out.